Okay, right. So let's look what we will be looking into and which things we will cover during the first day of Qt4 MCUs training. So this one. So as the first thing, we will go through the Qt4 MCUs package content. So we will learn what's inside what's inside the package that comes with Qt4 MCUs installation. So once you select that in Qt installer, what is really installed on your device. Then we'll see how to build and run your app from the command line. So the most raw and most basic case when you would like to create your application project for Qt4 MCUs and then compile that directly from the command line. So this point is exactly about this. This will involve some CMake APIs, so we'll also cover more of them. We'll look what are the responsibilities in Qt4 MCUs. If it goes about the CMake, we'll go through Qt4 MCUs application build process. It's a quite complex thing, so it's good to understand how the particular tools are doing that process, where the compilation is, and how the assets are working. This will be in that point. After those points, we'll have a short coffee break. So after getting some rest, we'll get back to see how to configure your Qt Creator installation to work with Qt4 MCUs and compile your apps for particular devices. And we'll follow that with a live coding session in Qt Creator. I will show you how to create your basic project, how to compile your first application using Qt Creator. And after that, we'll go for a bigger break. So we'll go to eat something during the lunch break. And after eating, we are going to see how to include some assets to your application, some images that could be displayed in your application dynamically. And we'll of course follow that with a live coding session that will show more in detail how to manage your application assets. And quickly about the second day of our training. So tomorrow we'll see what is different between Qt4 MCUs and Big Qt. We'll cover the topic about styling the controls, so any custom buttons, sliders, and so on. Styles will be also explained. The short coffee break will go there, and after that we will learn how to translate your app, so how to provide different languages for it. There is another lunch break, and finally quite a big topic about C++ integration to understand how connect your C++ parts of your app together with the QML code that defines your UI. Pretty interesting thing, and I hope you will learn something interesting. So getting started and directly from the software requirements. Microsoft Windows 10 is the only supported operating system right now. So if you would like to go through all live coding sessions, you have to work with Windows 10. Linux will be supported shortly in the 1.9 release. It's coming in the, I don't remember exactly, but it will be really shortly. macOS support is planned, of course, but we don't know when it will be. But if you are curious, if you are going to support macOS, we will, but we don't know when exactly. Of course, Qt4 MCUs 1.8 is needed, and you can, of course, download that directly from the Qt installer. And well, maybe let me show you more in detail if it goes about Qt Creator and Qt4 MCUs things, as you can install that directly from the Qt installer. So let me just open Qt installer. Well, here it is. So after running that, you have the login screen. So please just type your credentials there and click next. It will take a while to gather all the informations. Then we will select add or remove components. Click next. It will still take a while to download all the metadata there. All right, here we go. So just make sure that you have selected latest releases. So this checkbox has to be green. You can close the preview section. Additional libraries are not needed. Let's go to Qt. You don't have to install the big Qt. I have installed that for different purposes, but this is not needed. You just have to go to developer and designer tools. Let's expand that one. And of course, you need Qt Creator, you need CMake, and you need Ninja, which will be needed later on. And if it goes about Qt for MCUs, for sure you will need a desktop backend, which will be needed to test our application on the desktop, to not flash every time you made any change your app to the device. This will save a lot of time for you to test some of the UI changes directly on the desktop machine. And during this training, I will be using NXP board RT1050 evaluation kit. So if you're going to use that one, then just select the checkbox near the NXP IMX RT1050 EVK. And that should be enough for Qt for MCUs 1.8.0. And from the third-party tools, we will need ARMGCC8. This is the compiler toolchain for to compile the application for your target board. Oh, let me close this pop-up. And then there is NXP 1050 SDK, which is also the required thing. You can install that one directly from the installer. And we will need NXP MCU Expresso IDE to provide tools to flash your device from the host machine directly from Qt Creator. And if it goes about Qt installation, that's it. So normally you just click next. I will click close as I have all of those things installed before. Do I want? Yes. Okay. So as I said, this covers Qt for MCUs 1.8 installation for desktop and the board. Qt Creator is also included in that installation, and the CMake is selected from tools. There are also the Ninja. There's also a Ninja tool that I mentioned will be needed later on. And of course, for the Windows 10 and for the desktop backend, so to test your app on the host machine, you will need MSVC compiler that comes with Visual Studio installation. So let me open Visual Studio installer for it to show you what is exactly needed. Let's continue. Let it do something to start. If you have any questions during this training, just please use the Q&A section. I will try to answer all of those as soon as it's possible. It's a quite slow installer, so let's give it a bit more time. Okay, something is happening, but I'm still not able to see any installer. Oh, well, could I paste the link for MSVC here? I will try to find that out. Let me copy that. It should be there. Hopefully you will find out the installer and online installer here. But, I'm curious why it's not showing up for me. It's still processing something. Maybe let's use that moment once the Visual Studio installer is setting up. Okay, here we go. How to cancel? Okay, here it is. So once you have the installer ready, you will have to select one of the things. So Visual Studio Express 2017, you can choose, of course, some other installation, but depends on your selected the general package. You just have to click Modify, and you just need two things from there. Go to the individual components. And let's search for the compiler first, MSVC, and the required version is V142. So just let's select that one. And the second thing that is needed, it's Windows 10 SDK. So just let's type Windows 10, and then there is Windows 10 SDK that you just have to select. Okay, and there are some more questions. No, right now there is no free license for Qt for MCUs. You can contact us, but I see Jakub, who is my friend that is helping us today, is just right now typing the answer for you. But generally, no, it's not available. Let's wait for the answer from Jakub. And in the chat, okay, there is another link. Okay. So as I said, those are two things that are needed from Visual Studio installation. So basically, the MSVC compiler and the Windows 10 SDK that you have to install together with your Visual Studio installation. Those both things are needed by our Qt for MCUs desktop backend to compile your application for the host machine. Okay, one more thing. The documentation for Qt for MCUs is available online, and I can show you where. So here it is, doc.qt.io/Qt for MCUs. And here you can find documentation for 1.8, so for the most recent version right now. You can find all documentation for more detailed things like platform implementation details. You can find the general things that are common for all Qt for MCUs, some manuals, some tutorials, how to set up things. It's all online. Okay. Before we go further, I will share the link with you so you can prepare yourself for live coding sessions. Here we have a link to materials that I will be using during the training. You have right now a moment to download those before I will start coding anything. Okay, let's get back to presentation. This one, okay, this one. Okay, so this is about the setup of the environment and all of the things that are needed. And let's focus on package contents. So what comes with Qt for MCUs installation? For sure, you are receiving the quick ultralight graphics runtime, so the heart of the whole Qt for MCUs. So this is the engine that computes all the computes position of all of the controls that you are placing on the screen. This computes the refresh regions for your application. It controls the lifetime of it. And generally, it's common for all of the Qt4MCU ports for particular boards. Also, you will receive Qt Quick controls, which is a subset of Qt Quick controls that you can know from the big Qt. And also, you will receive default styles for it. And there's a platform adaptation for the platforms that you have selected during the installation. Previously, I was showing you to how to install that platform adaptation for NXP 1050, and this is exactly about those platform things. Development tools are also coming together with Qt4MCU's installation. You will receive the Qt Creator and all of the stuff that is needed to integrate it with Qt4MCUs. And of course, you will receive the Qt Linguist tool to provide localization support for your application. Offline documentation is included as well, and examples with source code are also delivered together with the installation. And the folder structure. This is something that I will show you directly on the file system. Well, here we go. This is the Qt installation directory, the root one. So just the C and Qt. And let me briefly go through for the things that are there. So maybe as the first thing, let's focus on the tools directory. This is the place where all of the tools that you're installing through the Qt installer are going into. And for example, we have a CMake there. We have a Ninja that we have installed before. And for example, there is also a Qt Creator tool, which is quite a big one, but still it's a tool. And this directory Qt MCUs contains only the stuff that is specific to Qt4MCUs. And as you can see, here is the ARMGCC toolchain installed and some NXP related stuff like the SDK for the 1050 board. And also there is an installer package for MCU Expresso IDE. Okay, let's get back to the root directory and let's see what's inside Qt4MCU's installation. And in the root Qt installation directory, you can find Qt MCUs. Then there is a version of it. And here it is, the root directory of Qt4MCUs. And let's go through all of the directories that are here. In the bin directory, there are located some tools that are needed during the compilation process, like tools for converting the images, tools for generating the C++ code from the QML, and so on. And as you can see, there is also a bunch of DLL files which are needed for Qt backend, for Qt4MCU's desktop backend, and by having those files, you don't have to install the big Qt, the whole big installation. You just have to point those files. We'll cover that later on. There is also a compatibility module, which provides some compatibility types and plugins for Qt tools to cover the types that are specific to Qt4MCUs and to still be able to use the types that are specific to the Qt4 microcontrollers. Demo images contains precompiled binaries for both bare metal and the FreeRTOS. Contains precompiled demos for all of the boards you have installed. In my case, it's quite a big set. Probably if you have selected only one board, it will be a few of them. And as you can see, these are compiled with different compilers and for different demos. The same goes for the operating system. Demos contains the sources for those precompiled images that I was showing before. Docs contains offline documentation examples, of course, contains sources for small apps that are showing some particular features. So if you are going to search for how some features are working, probably you will find the answer here. Include directory contains the general headers and the things that are needed during the compilation process. Of course, the kits are for Kit Creator to find out the configuration for particular boards, how to connect the compilers, the tools for flashing, and so on in the Kit Creator. A tool. Lib directory, of course, contains all of the precompiled libraries with for the boards that you have installed. These are libraries for quick ultralight, for the platforms, for styles, and so on. Platform contains platform-specific parts of Kit for MCUs. So, for example, for the NXP boards, STM boards, and so on. Plugins, of course, plugins for Qt tools like Qt Creator. And the source contains additional files that can be used in your projects to speed up the things. Most of them are common things that are prepared, and those are mostly the most basic implementations for example, some main entry points for apps, some code initialization, and so on. Okay, so this is about the installation of Qt and how it looks on your machine. And let's get back to presentation. I mentioned before about desktop backend, and this is a quite powerful thing. Even if it seems to be a basic thing, it really speeds up the development of your application for microcontrollers, as you can still run your app directly on the machine that is used to develop the product. You're saving a lot of time for checking small changes on your UI. You don't have to flash your device each time you are making a change. Okay, there's another question. Can we use Qt open source for MCU? Well, as I said before, the Qt installation is not needed for Qt for MCUs, and Qt for MCUs is not available for free. So basically, you cannot. This is the correct answer, but well, if you have the license for Qt for MCUs, you don't have to use Qt, let's say. So you don't have to have the license for both. Okay, let's get back, as I missed something probably. This is another point as well, that required Qt libraries are shipped together with Qt for MCUs. So, as I said, if you have the license for Qt for MCUs, you don't have to have additional one for big Qt. And desktop backend on the Windows 10, of course, is compiled with MSVC compiler, which is, of course, needed there. There is a plan to switch that to MinWG, but this is the future, and right now we don't know when exactly this will happen. And yeah, this is about the desktop backend. And here we are approaching the first live coding session, but before there is another question. Well, okay, right. So maybe let's get back for a bit between the, and I will answer the question. So the question is, what is the main difference between Qt for MCUs and Qt? And what are the advantages? So, well, Qt for MCUs is a completely new product. So this is the whole framework is written directly from scratch. It uses some parts of the big Qt, but in general, this is a completely new product. This is a lightweight version, really lightweight version that can be run on the microcontrollers that are really I would say thin and have no such a big power, and for sure you cannot run the Qt on the, for example, Cortex M4 with 1 megabyte of the flash and half megabyte of RAM, and you can do that with Qt for MCUs. And this is the biggest advantage of Qt for MCUs, that it comes with really lightweight support for the microcontrollers that are really cheap and does not have a lot of well, I cannot find a word for it, but typically the targets for Qt for MCUs are the boards with low resources. You don't have a lot of memory, you don't have a powerful GPU. Typically, you don't have the GPU as well, and all of those things are working fine together with Qt for MCUs just because it consumes a way less memory, a way less resources if it goes about the CPU load, and if there is any GPU load. And this is the biggest advantage, that Qt for MCUs is a completely different product, and it's a completely lightweight one. Probably we'll cover some more parts of the differences later on during this training. Okay, so let's get back to the live coding session, the first one for us, and what we'll learn during this live coding session. So we'll learn how to set up the CMake project from scratch. We'll build your application using the command line, and we'll of course run that up. Okay, so let me set up the things there, and okay, I will open the terminal window. I have prepared the training directory for our training meeting, and I will do all of those things just inside this directory, and I will start from creating a special directory for our new application. I will call it first up. And let's go inside that one. Okay. As you can see, it's empty, and right now I will open Visual Studio Code. You can choose any editor as you wish. It's not that important, just have something to write. And I will create a file, main.qml. Here it is. So we have our new file, which is still empty. And the first thing we'll need there is some import. Qt 15. In Qt for MCUs, the version of the import is not that important. It's just a good practice to put that there as Qt creator requires from us. The version, and it will show the error in the IDE once the version is not there, but as I said, it's just a good practice for Qt for MCUs to still put that version there, but it's completely omitted and it's optional for Qt for MCUs. And our app will be just a simple rectangle with a color magenta, and save the file. All right, and it should be it if it goes about definition of our user interface for now. It's quite a simple thing. And let's get to creating a CMake project. So once again, I will create a file using the Visual Studio Code, and it will be called CMake lists.txt. Okay. This is another empty file that we'll be filling. And the first thing in CMake is to define the minimum version that is needed. CMake minimum required. And it's version 3.15. Okay. Then we have to define the project for our app. It's first up. Okay, okay. And languages are also needed there. And we will use C++. We have to find the package. We'll provide additional CMake stuff for our application that comes from Qt4MCUs. And Qt4MCUs package in CMake APIs is called tool. Okay. And briefly, we have the project set up, but still we need to add the target. And to do so, we have to use one of the Qt4MCU specific macros. And this is the qul_add target. Okay. And the additional thing is to connect our QML file with our project. And to do so, there is another CMake macro, qul target QML sources. First up, and it's main.qml. All right, and the one missing thing for now is to have some entry point. And by entry point, I mean your application will have to define the main function. And Qt4MCUs comes with default implementation for those. And you can simply use one of the macros to use that default main entry point by default. And we will do that right now. It's up target default entry point. And that entry point goes for the first app. And we are going to provide the main root QML file, which is of course the same name. So just a name without the extension there. Okay, and right now there is a good moment to mention that some of the macros from Qt4MCUs package are starting with qul_, and some of them are starting with up_. And it's not a mistake and not any inconsistency. It's by design. So the qul_ macros are the essential ones and the ones that you are probably going to use in every application. And those are the mandatory things that are the part of Qt4MCUs APIs. And those with the up_, are something optional. So you can completely omit that part and you can define your C++ file with a definition of your main function, and then you can define all of the setup there, and you can run Qt4MCUs application directly from your custom file. And well, so basically qul_ also this is something needed, and up_, this is something optional. Okay, let's save the file and let's try to build that up. Maybe as the first thing, let's review what's inside the directory. And not a surprise, we have those two files that we have created. And right now, we'll have to define some environment variables to set up the environment for us. So for sure, we'll need to know where the Qt4MCUs installation is. And to do that, I will define the qul_dir environment variable, and I will point that to Qt4MCUs installation. So let's see, Qt MCUs and 1.8, and that's enough. Okay, and we will need the CMake, as right now I don't have any in my path. Yeah, I don't have. So let's set the path to, just please keep in mind to preserve the previous path content. So set path to path and then semicolon and directory of our CMake tool, and it's also under Qt tools, CMake, and the bin directory. Okay, let's verify if that works. CMake CMake version, and it works right now. Okay, and I think right now we can try to compile our app, and as it's always in CMake, we have to create another directory for build desktop. Let's go inside and let's trigger a CMake. Let's generate the targets for the parent directory. So for a directory that contains our CMake list.txt and the QML file. And then let's define some CMake variables. It will be a QL specific one. So we are building that for the desktop backend. So we have to provide the QL platform, which for the backend is just Qt. Okay, and it's for the architecture x64. Okay. CMake is now generating the targets for our app, and it successfully did that. So we can try to build our application. And to do so, we are just typing CMake, and let's build this directory with a target first up, and let's configure that to release. And well, here we go. A compilation process has successfully passed, so we can try to run our application. Release, and our app will be just the first app.exe. And what happened? The error happened, and that's normal. And as I previously said, Qt libraries that are needed to run Qt for MCUs application on the desktop are coming together with Qt for MCUs installation. So normally we just have to provide the path to tell the operating system where those libraries are. So let's close the error message and let's provide the path for those. So once more, let's extend the path by preserving the previous path, and we have to point qldir and then by bin directory. Okay, and we can try once more, and perfectly we have our Magenta application running. So this is the Qt for MCUs application running with Qt with the desktop backend. And as you can see, you can run such application directly on the device that you are using to develop the app. And you can wonder how to do the same for your device. And we will cover that right now. Let's get back to the root directory of our application, and let's create another directory for NXP board. Build_NXP, and let's go inside. All right, and well, we'll need some more environment variables right now, and to do that, let's set the first one for the compiler toolchain. It's arm gcc _dir, and it's also located under Qt installation directory. So let's go to C, Qt, tools, Qt MCUs, arm gcc 8. Okay. Some environment setup is also needed for the board itself. So we have to tell the Qt for MCUs where we have the SDK for the particular board, and to do that, I'm defining another environment variable that is specific to Qt for MCUs, evk b_imx rt 10 1050 _SDK path. And we have to point to Qt installation directory once again. C Qt tools, Qt MCUs, NXP, and there is the SDK that we have installed in the Qt installer. Okay, let's set that. And also there is, if you are going to flash your device directly from the command line, you have to tell where the tools from NXP that does that are located, and we will define another environment variable, MCU express IDE underscore path, and it's under C Qt. Oh, sorry, it goes to default C NXP installation. It's a separate tool that it's not from Qt, so it's installed outside. MCU Express IDE, I have 3 versions of those, so I will choose the most recent one. And let's set that. Okay, and the last thing to cover in the environment setup is to extend the path once again with the path to Ninja. It will be needed to generate the CMake targets in a different way than for desktop. So once again, path was extended with C Qt tools Ninja. Okay, and let's verify Ninja. Ninja version, it is. Okay, perfect. Okay, and right now we can generate the targets for our application in the CMake. So CMake double dots, so for the parent directory, and let's pass some variables to the platform, and it will be different. So okay, T1050 EVK, and let's see. Let's notice that we have the name of the board. So MIMXRT 1050 EVK bare metal. So we are providing also the operating system or no operating system in the Qt platform. And then the build type for the CMake. So the CMake build type, and let's pick debug this time. Okay, and we have to tell that we will be using different compiler for the board, of course. So the CMake toolchain file, and this will be quite long, but hopefully we'll get out from that. Okay, killdeer, and let's focus right now. So it's coming from killdeer environment variable, then in lib, then CMake, kill, toolchain, and arm gcc.cmake. CMake, okay. And last thing, to pass the generator Ninja. Okay, and hopefully it will work. Let's hit enter, and okay, perfectly. Here we go, and we have generated targets for our NXP 1050. And let's try to build our application. And to do so, we are just right now using Ninja, so it's easier. Just let's type Ninja and first up. As you can see, the building process is ongoing, and okay. So the build process has successfully finished, and let's try right now to transfer our application to the board. But before that, there is okay, there is a message from my friend. So okay. So just let's continue. Okay, so right now I will just show you what I will type in the command line. I will type ninja flash first up, and those flash underscore and then a target name targets are the things that are coming together with Qt for MCUs, and those are prepared to automatically flash your device if it's connected. It's using some tools that are coming from the vendors of the boards, from various vendors for various boards. In our case, it's using the RedLink toolchain from the NXP. From the NXP IDE installation, and I will just hit enter in a while. But right now I'm switching the view to additional camera to show you what will happen on device. So right now you should be able to see the board that does displays the hello world, and I'm hitting the enter right now, and it should flash our board with new content, new application that will be hopefully our magenta one. And here it is. You have to trust me that it's magenta, but it really is. And just the quality of the camera is not good enough to display the exact color of it. And okay, let's, in this case, get back to sharing the screen. All right, here's the output from the flashing. And this is how it basically looks like. If it goes about building and transferring your app and running it across the devices or the host, using just the command line tools and just the environment that is set up directly in the command line. Okay, so we covered all the things from those 3 points. So let's go further. And this is the summary of the things we just did. So to configure your project, you have to create some specific application directory. You have to, of course, create the files and so on. You have to provide environment setup. So you have to define the QDIR directory that will point to your Qt for MCUs installation one. You have to create separate build directory for your CMake targets and all of the CMake generated things. And of course, you have to provide some CMake variables to define the platform, to pass different toolchain files that will switch your compiler. And well, to build that, you can use the default CMake syntax, and that can be a long one. And of course, you can use the Ninja generator, for example, that will short up the things. And I think that's it. And just keep in mind, and just remember to extend the path with the Q installation directory and /bin to have the visibility on the libraries that comes together with Qt for MCUs installation to run your application on the host machine. And as you probably saw before, I was using some of the CMake APIs to control. Okay, there is a question. Could you show the flash command, and would this have to be set up for new boards using the board tools? I'm not sure I completely understand the question. I can show you the flash command. Okay, here it is. So for the boards, you have automatically generated flash targets. So you don't have to type your whole flashing command using the tools that are usually hard to just type in your terminal. But in the Qt for MCUs generated targets, you have that one. So you can just use flash underscore first up, and that will cover the flashing commands underneath. It will use the tools and the configurations that are already prepared for you. And basically, except defining some environment variables to tell your system and Qt for MCUs where those tools from NXP are lying, or for the compiler or so on, there is nothing more you have to do. It will automatically generate it if only you will provide those variables I was showing you before during the environment setup. So basically, well, this is the command that you would like to run, ninja, then flash underscore first up. And this is the only thing you will have to run to finally flash your device. And of course, here you can find the whole output from it after the flashing is done. So basically, ninja, once again, flash underscore first up. Hopefully it will answer your question, but nothing specific besides setting the environment variables is needed to have those flash targets. Okay, I answered. Okay. Perfectly. Okay, so let's get back to the CMake APIs. And as you saw before, I was using a few of them to control how Qt for MCUs compiles and how Qt for MCUs connects QML files together with the application target and how to define some default entry points. And right now in this section, this part of the training, I will cover some more of them, and I will tell you what are. Oh my God, my mouse is switching the slides for me. Sorry about that. So let's focus on those, and let's start from the Qt platform. We were using that in the first live coding session. This parameter, this CMake argument variable, is telling Qt for MCUs which platform you are going to use right now when generating the targets. So Qt is a default one, and as well it's a target and the platform for desktop backend. And it means simply that by compiling for this platform, you will be able to run your app directly on the device that you are using for developing. All other platforms are defining the real hardware, that is the MCU hardware. And as you can see, this could be a STM board, this can be a NXP board, in our case, the second one, the 1050 VK bare metal. Of course, it can be the FreeRTOS to switch the operating system. The Renaissance boards are supported, and so on, so on. And this is to define which board you will be using. QL color depth is defining, in fact, the default color depth for your frame buffer. On the boards that are using the only single frame buffer, it's generally the default and the target color depth for the frame buffer. So it must be one of the 8, 16, 24, or 32 bits. It will define the color depth, and by lowering the value, you will of course lower the amount of memory that is used for your frame buffer. And going higher, of course, you will bump up the memory consumption for the frame buffer. And of course, it will increase the time that is needed to draw your things on that buffer, or as it will require more pixels to be drawn. But as I said, this is the default and the target one for the boards that are using the single frame buffer. But there are also the boards that have a concept of layers. I can cover that later on during the on the end of the training. But those are using multiple color depths, and this will be the default one then. To create the application target, we have our Qt for MCU specific QL@target macro, which takes the name of your target. It can also take the additional argument that is different from the @target that comes by default from CMake. And that means if you are using the static library argument, it means you are going to compile your application, your Qt for MCUs application, as a static library. And then you can link that library to your final application, your final binary somewhere else. And this is pretty useful if you are going to create some bigger product and it will allow you to create some such static library instead of the final binary that is prepared to be flashed on the board. Of course, there is also a list of the sources that could be added to your application, and there is below that there is an example. So for the example app, you're providing some sources, source 1 and 2. To add the QML files to your project and connect that to with your target, we were also using that one, target QML sources for the target, and there is a list of the QML files. Of course, there is also a bunch of handy arguments, additional arguments, like the output directory, which will redirect your artifacts from the compilation process to some specific directory. There is also a module URI, which is currently the deprecated API since the version 1.3. It's the old way of creating modules for your QML files and QML structure. And there's also a copy QML files optional argument, which tells that the source QML files that were used to create artifacts are also copied together to output directory. This could be pretty useful when you are going to reference those QML files later on during compilation process. If it goes about application entry point, let me just take a bit of water. It's really a lot of talking for me today. So to define default application entry point, you can use the set of the app underscore functions and or the macros. And first of those is the app target default entry point, and this is tying up the target, so your application, together with the root item, so with the root QML file that will be a start of your application UI. And well, it provides the default implementation for the main function, for initialization of the board, and the QL itself. It will run the exec function, which is the permanent loop that that takes care about your whole application lifetime and whole rendering loop inside. And of course, this function template depends on the OS and the target type. So this directly goes to the another macro that is a second one on this slide. So it will behave differently and will take the different default entry point if you are going to use, for example, operating system. As operating system itself needs some initialization as well, then those default entry points will differ a bit. But still, Qt Frame's use will be initialized almost the same. To create a QML module, there is a new API. Previously, I said that there is some deprecated property in one of the macros, and this is the new way of doing that. So here we are providing the target, of course, and the URI that you will be using further to reference your module in other QML files. Of course, list of QML files is going there, some headers if any are needed, some sources as well, some imports that are used across your module, and of course, output directory that can be used to define where your artifacts should be located after the compilation process. And this is also the way, and that is the only way, and that the required thing to create the QML singletons. So if you are going to create a QML module, the QML object, some type that you would like to reference across all of the QML files globally, you are going to create a singleton, which can be created only by calling this macro. There are also some other commands for adding the resources. There is a ql add resource. And this one is pretty simple. So you're just providing the target and the files for it, some PNG, JPEG, and so on files. You can define the prefix. We'll explain that later on. Base, this is to shorten or extend the path that you're using to reference your files in the QML then. And of course, the output directory to redirect your artifacts. For translations, there is a macro that will embed your translation files in binary form in your final binary of your application. And to integrate your C++ code, there is a QL target generate interfaces macro that takes header files that are converted to QML interfaces during the compilation process, completely seamless for you. Well, this is for the second day of the training. We will also be using that later on. Some properties related to fonts, QL font 0, will define where your fonts are located. By default, it's located in one of the subdirectories of Qt4MCUs installation path. As you can see, it's in the installation path /source third-party fonts, and the default fonts are lying there. And by switching that property, you can show Qt4MCUs build structure where additional fonts that you will reference further are located, and this. Which fonts you are using can be switched by QL default font family and by other ways as well, but QL default font family is to set that globally. So you can just define a default font for the whole app without switching the font.family property for text and the static text components in each place. Some properties, variables related to QL texture cache, to resources. So this is the QL texture cache, and this is the super important one, and it's related to cache mechanism, and this defines the maximum size of the image cache, so the maximum size of bytes that your image cache can handle, and the first most important thing regarding this variable is that it has to be defined before calling add executable in the CMake. Otherwise, it won't work. And well, it's required if you are using image compression, and or if you are going to copy your files from the flash to RAM. But basically, it will mean that if you are going to use compressed images, those will be decompressed in the runtime, and that decompressed data have to go somewhere. And the image cache is the place where those decompressed data is going. And well, it has to be big enough to fit at least the biggest image after decompression. And the formula you are seeing on the screen right now is to compute the minimum and at least the size of the image cache that has to be set to work properly. Because if you will set this to too low value, it will not. The biggest image will not fit in the memory, and your application will simply stop working. And from the other side, if you will set this value to big one, you can overlap other parts of your code in the memory or your application, and this can lead to, in the best scenario, bad performance, and in the worst scenario, some malfunction on or undefined behavior. So this variable is really important one, but it should be used with special care. Some additional things, you can enable generating JavaScript bytecode by defining QL debug bytecode. This will be then generated as a comment to the right side of the code from the artifacts of the build process. Ql debug line directives is enabling generating the line directives that will point back to your QML source, as all QML sources are converted to the C++ during the compilation process, and then that C++ code will have the line directives, which will point back to QML source and will tell your debugger where to place your step instruction, let's say. So you will then know which line of the QML source was responsible for particular situation in the code, some auto-generated code. Okay. This was a lot of the CMake stuff, so let's right now switch to other topic, which is the Qt for MCUs build process. And that one is a quite complex thing, but we'll go through all of these steps to understand how your files are processed, how artifacts are processed, and when all of those things are combined together, and why all of those works. The first thing is to define of course, your project in the CMake list.txt file. This will tell Qt for MCUs how to process and which file to process at all. So this is the complete start to have the CMake list.txt file, and depends on what's there. We are going through these steps, and let's focus on the left side on the images. So the first thing is to compile the resources. So all of the PNG files that you added to your application are going through the tool that is called curl_rcc, and this tool is converting all of those images to the formats that are known and needed by Qt for MCUs, and those will be C++ files at the end after the curl_rcc will finish its job. And those C++ files will contain the bitmaps in the normal CRIs of the given format. For example, ARGB32 or Alpha 8 or so on. If you are going to use the compressed format, curl_rcc will compress it again and will put the image in the format that is known for Qt for MCUs. Then there is a time to compile the fonts. So Qt font compiler is another tool that will take the font file of your app and will generate another C++ file with another set of CRIs that will contain glyphs, pre-rendered glyphs for your app. And your app will decide, not app, the Qt font compiler will decide which glyphs to pre-render, depends on the text and the letters and glyphs used in your QML files. And only those glyphs that are used in your app will be generated in ql_fonts.cpp file. And if you are going to use more of them, there is a way to extend that, but we'll cover that later on. After assets generation, there is a process of converting your C++ interfaces to provide QML representation of those. So Ql interface generator tool will take your C++ header files and will convert those to QML representation by passing all of the properties, names, and so on to QML code that will be needed by the next step. And the next step is converting the QML files to the final C++ representation. And this is a super important thing to understand, that in Qt for MCUs, every QML file is converted to C++. And finally, the C++ representation of your UI is the thing that is running on your board. And Ql to CPP tool is converting your QML files, and those which are the your interfaces representation from the previous step, and on the output, we will have another set of C++ files with a definition of all of those UI related things from the QML. And finally, we have the compilation process, C++ compilation process. So any compiler that is needed for you, so MSVC or I don't know, ARMGCC, Greenhills or others will go there, and this will take the files, the C++ files from your application, C++ files that are auto-generated, and optionally the default main entry point that can come from common macros. Compiler will compile all of those C++ files together. And then finally, the linker will link all of the symbols together, as well with adding the libraries with Qt Quick Ultralight and platform abstraction, and possibly other things that are needed by your application. Well, and finally, you will have the app that can be flashed on the board. This could be quite a complex thing, but the question, if you have any questions regarding this part, if so, then just please let me know by the Q&A section, and I will go to the next slides. And those will be about the tools that were involved in the compilation process that I just explained. And the first one, QRCC. It's a tool to convert the images to C++ representation. So it also follows some loading policies, so you can decide if your assets are located on flash or they has to be copied to RAM during the startup. This tool can optimize the image for some graphical transformations, so you can decide if particular asset is going to be rotated or scaled, and then QRCC will mark that file for the platform that this file, this asset, this resource is going to be rotated, and then the platform can do a special thing. For example, it can put that to the faster memory for faster access, and then the rotation will be faster. But this will be done on the platform, and QRCC is just following the optimization flags and also the loading policy. It will compress the image if it's needed. So as I said, even if you are providing the compressed format, for example, PNG, but you still would like to have the compressed format in your Qt for MCUs application in the runtime, it will, let's say, recompress. So it will compress the image in the format that Qt for MCUs is expecting. Some platforms have the custom formats that are used to compress the images, and it's also prepared for that. And well, yeah, the output is the normal C++ RI, the byte array, and the images are stored normally with as the bitmaps and in the compressed formats, of course, as the compressed formats, the binary format. Qt font compiler is used to generate the glyphs, and it's stored those glyphs as arrays, the alpha maps, normally in the alpha 8 format. You can change that. You will be able to change that in the future by using new APIs for controlling the font quality, but right now it's only in the alpha 8 format. Well, glyphs are generated, as I said, automatically based on what glyphs you are using in text in your app. It can be overridden. You can define and extend the glyphs range by providing additional sets of the characters to pre-render. And the super important thing, of course, is that every font size will generate another set of the glyphs. So, for example, if your app is using 10 glyphs, but you have 2 text elements, and one of them is using text font size 10 and another one 20, it will create 2 sets of the glyphs, one for the font size 10 and the second one for the font size 20. And that's also important thing if you are taking if you are paying a lot of attention to memory consumption. QML interface generator, it's used to generate the QML components based on your C++ headers. Those will be used then by other tool to connect your QML code together with those QML components. It forwards properties, signals, functions to QML directly. So you can define, for example, the public method in your C++ class or struct, and then it will be accessible in the QML code as a normal QML function or the JavaScript function. Well, QML to CPP, of course, it's used to convert every QML file to C++. Every QML file in Qt for MCUs is converted to C++. Well, this is how it works. And initialization code is also added there. So if your C++ representation of the QML component needs any initialization, it's also already there, and for you, it's completely transparent to use that tool. And before we start using all of those features, I'm inviting you to a short coffee break, which will take 15 minutes. It's also a good time for right now to sum up some things. So if any of you have any questions, please ask right now. If not, I will start the timer with 15 minutes break. And we'll see each other after the break. No. Then coffee break. Okay. Okay, there's a question. Will we receive the URL of video recording? Sure, of course, it will be available for you. Of course, after the whole training, so it won't be available today after today's training. So tomorrow or in a few days after tomorrow's training, it will be on your email. May we have a summary of the environment variables to compile the application? Well, okay, I will just, before the coffee break, put that on the screen, and just let me a while to prepare that. So just let me do that. I will click the coffee break timer just when I show you, when I will show you the environment setup. Some information about the tools that are involved in the compilation process are located in the documentation itself. There's also a quite good porting guide that normally is not related to that things, but also contains a bit of information about those. It's also available online in the same place as documentation. But well, that's it, I think. If you are going to, if you need to know more about those, you can always ask the us on the training, during the training. And if you are going to develop the product, you of course can have support of us, and this is also part of the code that is delivered together. Okay, well, let me prepare the environment.